Sulphur. Delicate, valuable, and temperamental. Its unique qualities make it almost impossible to safely transport via a cross-country pipeline. Harsh environments, uneven terrain, and extreme temperatures can wreak havoc with maintaining a uniform temperature for the entire length of a sulfur pipeline. The greater the distance, the greater the difficulty. Technologies have come and gone unsuccessfully, until now. With the right technology, people, and processes, Pentair has overcome the odds and created the ultimate solution, ushering in a new era of sulfur pipeline transportation. Sulfur has a finite operating temperature range, often within 20 to 35 degrees Celsius of its solidification temperature. It requires an average temperature of 135 degrees Celsius over the entire transport process, and heating it to excessive temperature degrades and thickens it. This is known as increasing its viscosity. Solidification is a reality during the operational life of a sulfur pipeline, and it's vital to provide a safe and reliable remelt procedure, which minimizes expansion forces and other stresses on a pipeline. When engineering sulfur pipelines, various design parameters, including service temperature, anticipated pipe movements, and more, must be taken into account to ensure that pipelines perform properly during heat-up events.
A sulfur pipeline presents many unique challenges. These could be pipe supports and anchors, pre-insulated pipe, just the way the piping grows and moves when it expands and cools. These are all dynamics that are critically important to understand.
Molten sulfur is normally operated between 130 and 145 degrees C. If you get out of that range, you're not able to pump it.
It works in a very tight temperature band. If it goes lower than that, it gets solidified. If it goes higher, over 155 degrees C, it becomes highly viscous. Managing that contradiction is one of the biggest challenges.
STS, or the Skin Effect Heat Tracing System, is designed to maintain a consistent temperature range throughout the entire pipeline, regardless of fluctuations in environmental conditions. The STS system consists of a thermally rated, electrically insulated conductor installed inside a small diameter carbon steel seamless pipe, known as a ferromagnetic heat tube, which is welded to the service pipe. An alternating current, or AC, voltage source is connected to both the heat tube and STS wire at the power connection. Because the STS wire is connected to the heat tube at the opposite end termination, it creates a complete circuit which allows AC current to flow down the wire and return on the inside surface or skin of the tube. The resistive properties of the carbon steel tube produce heat in the ferromagnetic tube through the effects of two well-known electrical phenomena, skin effect and proximity effect. This heat is transmitted to the pipe via conduction and in turn heats the sulfur contents to a predefined temperature range.
Predominant way they were doing sulfur transportation was by heater trucks. But the problem with heater trucks is that product inside is 140 degrees C. If you can transfer that in a pipeline, it is a lot safer and sensible to do that way. STS technology itself is very, very old. If it is a conventional tracing, you probably may have hundreds of circuits. STS technology allows to self-limit the heat output so that you will not overheat it or underheat it. The electrical flux becomes concentrated on the inner skin of that heat tube so that the outside is voltage and current free.
Pentair's STS sulfur pipelines consist of a thermally insulated carrier pipe with an inner layer of expanded perlite and an outer layer of polyurethane foam. These insulation layers are completely protected by durable outer jackets made of a high-density polyethylene and aluminum, providing the system with multiple layers of protection for the electrical heating system and reliable, uninterrupted service for years, even decades. Power is then supplied through dedicated substations, which supply power to the STS heat tubes on the two 12-inch diameter pipelines, and the design requirement typically dictates that each pipeline include two STS heaters in order to provide 100% redundancy. Pull boxes attached to the pipeline approximately every 75 meters enable the STS heating wire to be pulled through the entire length of the heat tube, cleanly and efficiently.
The system is designed for a very long system life. Even though it's a robust and unitized system attached to the pipeline, you can easily replace components. If the heater cable in the future was ever damaged, it can be easily removed and replaced by accessing the damaged area pull boxes. You can pull out that cable section and replace it. During the design phase, our finite element analysis software allows us to thermally model the pipeline and the sulfur to determine properties such as cool down rates, heat up rates, thermal loss, and incorporate those into our design parameters.
Other technologies like fiber optic distributed temperature sensing, or DTS for short, can be bundled to enhance the performance of pipelines. Pentair is the only heating technology solutions provider in the world with a proven track record of effective DTS integration into the sulfur pipeline system technology. The DTS system consists of a specialized fiber optic sensing cable placed inside a stainless steel capillary tube, which is then surrounded by spiraled protective wire armor. The armored cable is then pulled through a dedicated carbon steel encasement tube welded to the carrier pipe at the 12 o'clock position. A laser light source is used to send pulses of optical light into the glass cable, and as each laser pulse passes through the optical fiber, it generates light variations or inconsistencies known as backscatter that travel back through the fiber toward the light source. The DTS system can measure the temperature for every point along the fiber optic cable. This unique feature makes the DTS system extremely useful during the heat up of the empty pipeline and also during sulfur introduction and normal operation. But it is the system's utilization during the remelt process of solidified sulfur that makes it the most valuable. DTS technology monitors the fiber optic cable, allowing accurate and timely notifications to an operator regarding the position and intensity of any extreme temperature event along the cable that could jeopardize the flow of the sulfur pipeline. This makes the remelt process predictable, safe, and reliable.
If sulfur solidifies, it loses about approximately 8 to 10% of its volume. So if you can imagine a 1 kilometer line, 100 meters will be vacuum. That portion will be much higher in temperature. So the problem is that now, where that empty space is going to be.
The biggest advantage of using DTS is it gives you the temperature information for the entire length of the line. You're not limited to 4 points on a 5-mile pipeline. That is critical, especially during remelt. If sulfur for some reason solidifies, thermal intelligence will allow you to see places where the temperature is getting extremely hot, so you know exactly at every meter on that pipeline what the temperature is.
In addition to the DTS system, the pipeline's mechanical design is critically and rigorously monitored to ensure they perform as a seamlessly engineered system.
The advantages of skin effect technology are to combine all of the components necessary under the insulation to make that an electrical system. That electrical system will ensure that the entire pipeline is heated from a central location. Traditionally, pipeline supports and anchors have very high thermal losses, which is detrimental to any heating system. The anchors and support shoes for the pipeline carry the dead load of the pipeline and also the axial forces generated by heating the sulfur pipeline up to its expansion point. A combination of high-density insulation materials and very low thermal conductivity insulation materials solves that problem.
Pentair's revolutionary technology allows the safe transport of sulfur over long distances while offering significant cost savings to clients through manpower savings, compressed production schedules, and reduced risks.
The skin effect heating system is designed to withstand desert environments, Arctic Circle environments, jungle environments. This is a very robust system that can last for decades.
The cost benefits of using the skin effect are that it is a very flexible system to operate. You only need to heat a pipeline under certain circumstances, therefore minimizing your operating cost. And with some of the adjacent technologies that we offer and recommend, like fiber optic temperature monitoring or leak detection, those kind of adjacencies can even increase the reliability and the safety of operating a pipeline.
Pentair's strength lies in the ability to seamlessly execute an integrated technology implementation strategy as a single-source integrator with a full portfolio of technology and service solutions, ensuring the safety and reliability of any long-distance sulfur pipeline. With global presence, technical expertise, and leadership, Pentair has taken on the biggest challenge in sulfur pipeline transportation and have conquered it against all the odds.
There's no other company in the world that can match Pentair's expertise and experience in sulfur pipelines.
We are the single source efficient solution for their heating problem.
It takes a multidisciplined approach, and to understand all aspects of a sulfur pipeline is critical. Pentair is in the business to deliver unique solutions that the customer can operate safely and consistently for years and years.
Pentair, inspired solutions for a changing world.